Let's look at another example. Don't forget, also in logarithm, you have to be able to express numbers in powers. Log 8 base 2. How do we solve this? Log 8 base 2. Let's have a log 2 base 2. 8 can be written as 2 raised to power 3. 8 can be written as 2 raised to power 3. Then this becomes, now this is what we do in logarithm too. I'm giving you the logic, that's what we need, the keys. The power now crosses to this other side. The power crosses to this other side. Becomes 3 log 2 base 2. Let's go back to this again. Log 8 base 2 can be written this way. Log 8 can be written as 2 raised to power 3 base 2. Then equal to this power of this log crosses to this other side, comes to this other side, becomes 3 log. We are left with the base now, 2, the logarithm, 2 base 2. So log 8 base 2 can be written as 3 log 2 base 2. And this is the final answer. Any logarithm that is whose base is the same as the logarithm itself, it is equal to 1. Log a base a equals to 1. Log 10 base 10, log 10 base 10 equals to 1. Any logarithm that has its base as the same with the logarithm itself is equal to 1. Log 1 base 1 equals to 1. Log 100 base 100 is equal to 1. So log 2 base 2 is equal to 1. Then we are having 3 times 1, which gives us 3. So log 8 base 2 is equal to 3. For this kind of question, don't use a calculator. If you're the type who uses a calculator, don't use your calculator. Because calculator is programmed to have its base as 10, like I said earlier. So if you punch log 8 base, log 8 using a calculator, you will see something like a 0 point. Then you become confused. So this is how it should be done. Log 8 becomes 2 raised to power 3 to base 2 is equal to 3 log. This power becomes here log 2 base 2. Any log that has its base as the same as the log becomes 1. Log 10 base 10 is 1. Log a base a is 1. So log 2 base 2 is 1. So we have 3 times 1 gives us 3. Log 8 base 2 equals to 3. The final answer is 3. Now let's have another one. Okay. This also I found in, all these questions are from our past questions. JAM, WAEC, NECO, GC, and all of that. Find K, given that, find K, given that log A, okay, log K minus log K minus 2 equals to log 5. Find K given that log K minus log brackets of K minus 2 equals to log 5. You can see in this now there are no basis for the logs. We assume that it is in a natural base. You can put any base you like, so long as all of them have no base. You can put any base you like. But that is not the main issue now. How do we solve this? That is the question. Like I said earlier, the same rules that apply to this apply to logarithm. Log K minus log this equals to log 5. Don't forget, in indices, a raised to power 2 times a raised to power 5 becomes the two a's, pick one, Because the bases, the powers, the bases are the same, you pick one of the base. The powers now, we add because it is a multiplication sign. Becomes 2 plus 5. When multiplying, you add the powers. When dividing, you subtract the powers. Now, we now turn it around a bit. Yeah. Log k minus log k minus 2 equals to log 5. This means log k divided by log k minus 2, this is what we have, equals to log 5. Because of this minus sign, separating these two logarithms, we divide, just like we learned from the rule of indices. Log k divided by log k minus 2 equals to log 5 on the other side. The two of them are logs. Let's factorize. They have log, factorize. Log, bracket open, k all over k over 2. This logarithm is common to the two of them, so we have it outside. We are factorizing. Log, open bracket, k all over k minus 2 equals to log 5. Don't forget, this is the minus sign. We divide, just like we learned from indices. Indices, when you see division, you minus the powers. But here, when you see minus, you divide. So log k divided by log k minus 2 equals to log 5. Log k, we are factorizing this now because they have something in common, log. So log outside, open a bracket, k all over k minus 2, close the bracket, equals to log 5. At this point, we do log cancels log. Then we are left with k minus k over 2. K divided by k minus 2 equals to 5. By cross multiplication, this way, k equals to this multiplies this multiplies this. 5 is the same thing as 5 over 1. So, by cross multiplication, k equals to 5 now multiplies all of this. 5 is the same thing as 5 over 1. So k multiplies 1, k equals to 5 times k gives us 5k. 5 times k gives us 5k. 5 times minus 2 gives us minus 10. Again, let me put it this way so it makes for easy understanding. 5 brackets k minus 2. That's cross multiplication. Then we have it this way. K equals to 5 times k, 5k. 5 times minus 2, minus 10. Let's collect like terms again. 5k crossing the red C, the equality sign. We have k minus 5k equals to minus 10. We move forward. K minus 5k, just like saying 1 minus 5. K minus 5k gives us minus 4k equals to minus 10. Like I said earlier, this one has minus, this one has minus. Just cancel the minus. We are left with 4k equals to 10. Therefore, k equals to 10 all over 4, which gives us 5 over 2 equals to 2.5. 5 over 2 gives us 5 over 2. So k equals to 5 over 2. K equals to 5 over 2, or if you want to go further, equals to 2.5. Don't forget, we have the negative sign here. It means we are going to divide these two logarithms equals to this other logarithm on the other side. So log k divided by, because of this equal minus sign, divided by log k minus 2 equals to log 5. These two log have the same thing in common, which is log. We're factorizing log bracket open k minus k divided by k minus 2 bracket close equals to log 5. Log cancel log on the other side. So k, we are left with k over k minus 2 equals to 5. By cross multiplication, k multiplies the 1, which is assumed to be under this 5. K times 1 gives us k equals to 5 times k minus 2, which we have here. 5 brackets k minus 2. K equals to 5 times k, 5k. 5 times minus 2, minus 10. So, collecting like terms, minus 5k crosses to this other side, becomes minus 5k. K minus 5k, this k minus 5k equals to minus 10 that is already standing there. So, k minus 5k is minus 4k equals to minus 10. Minus cancels minus here. We are left with 4k equals to 10. K equals to 10 divided by 4. 5 over 2. When you divide, express in the simplest form, 2 here 5, 2 here 2. So 5 over 2 is 2.5. You can leave it this way, you can leave it this way, you are still correct. So that is that about logarithm. We are trying to tackle these topics from all angles, such that even when the examiner comes from all other angles, you will still be prepared. You'll be able to tackle it. You'll be able to answer the questions. Now we are looking at another example. Example 3. Where we have this log 10 base 18. This, I think we have it in 2012, because I studied their trends and patterns from 2009 to 2019 rather. So I think we have this one in 2010. Log 18 base 10 minus log 288 divided by 100 base 10 plus log 16 base 10. Look at this. All of these are in base 10. Good. Now, how do we solve this? When you see this kind of question, don't look at it as though it's going to be difficult. Your ability to simplify them will make it easier for you to solve. Now, log 18 base 10 minus log 288 over 100 base 10 plus log 16 base 10. Don't forget BODMAS, the brackets of division, multiplication, addition, and subtraction. We are dealing with addition first before subtraction. Now, that means we are going to be having log 18 base 10 plus log 16 base 10 minus log 288 over 100 base 10. This plus this minus this. Deal with plus before you deal with minus, according to the BODMAS. So this plus this minus this. These two have logarithm in common. Let's factorize log 10, 18, plus, just like in indices, when you have times, you plus, you add the powers. Now, when you have plus here, you multiply the logarithms. 18 times 16 minus log 10 288 all over 100. Log 18 plus log 16. The two logs, they have log 10, log 10, log 10, 18 times 16 because of the sign plus. Then we have minus. The minus now becomes divide. divided by log 288 all over 10 base 10. Then we have it this way. Log 10, 18 times 16. 18 times 16 gives us 288. 2 times 16 gives us 288. Divided by, because division sign, because this minus becomes divide. Divided by log 10, 288 over 10. 288 all over 100 rather. This will take us back to reciprocal law we learned. This takes us back to the reciprocal law we learned in primary school, junior level, secondary level. And you have 2 all over 3. This 3, and you want to change this division sign to multiplication, or let's say we have 2 divided by 3. It can be written this way: 2 times 1 over 3. 2 times 1 over 3, because you want to change the division sign to times. This is what I'm saying. Let's say we have 5 all over, 1 over 2. 1 over 2 now is the denominator, 5 is the numerator. To change this division sign to multiplication, we have 5 times 1 over 2 becomes 2 over 1. Meaning what we have here goes up, what we have up comes down. So this becomes 10 over 1. So, meaning that log 288 divided by log 288 over 10 is the same way, we can be written the same way as log 10. They have the same log in common. Now let's deal with the other side. 288 times 100 over 288. We are saying 288 all over 288 over 100. Don't forget, this 288 over 100 is the denominator. That's what we are saying. This 288 over 100 is the denominator. We want to change this division sign to multiplication. We have 288 times 100 all over 288. That's what we have just done here. All over 288. So, I have told you, even calculator, you don't need it in this. It's so easy that you might not even need a calculator. So 288 cancels 288. We are left with log 10, log 100 rather, base 10. Log 100 base 10. Log 100 base 10. 100 can be written as 10 raised to power 2. 100 can be written as 10 raised to power 2. So like I said earlier, this power of the logarithm comes to the other side and becomes 2. And we have log base 10, log 10 base 10. This 2, which is the power of 10, crosses to the other side and becomes 2. We have log 10 base 10. I have said earlier, we've learned earlier that when the logarithm has the same base, then it is equal to 1. This is log 10, has the same base as 10 again. So this log is equal to log 10 base 10 is 1. Then we are having 2 times 1, which is 2. 2 times 1 is 2. We use a calculator because it is already base 10, and the calculator is programmed to have the base as 10. When you punch log 100, you have your answer as 2. To get that, this is how to get it. Log 100 can be written as 10 is equal to 2. We have our base 10. The 2 comes here. 2 log 10 base 10. Then log 10 base 10 is 1. Anything to its any logarithm that has the base as the same thing as the logarithm itself, it becomes 1. So 2 times 1 is 2. Now let's look at another example. Example 4. Example 4. We have here log 270 base A minus log 10 base A plus log 1 over 3 base A equals to 2. One thing about this topic is you will always find them in your exams. Looking at studying the trend and patterns of the examination body, you see that from 2009 to 2019, this topic will always be there. OBJ and theory, you have them there. So it is better you pay attention here to have an understanding of what we are talking about here. So log 270 base A minus log 10 base A plus log 1 over 3 base A equals to 2. That's the question. How do we solve this? Don't forget what we did the first time, the other time. Let's use our board mass again. This can be written this way. Log 270 base A plus log 1 over 3 base A minus log 10 base A equals to 2. Following the board mass rule, let's treat the addition before we treat subtraction. BOD-MAS, addition comes before subtraction. Now, that is rearranging this question based on the board mass rule. Log 1 over 3, we have something log 1 over 3. Okay, let's go further. These are the same basis, the same logarithm, the same basis. So we have log A. Let's factorize this. Open the brackets. Whenever you see the addition sign, you multiply in logarithm, just like we let in indices. It's just the other way around. 270 times 1 over 3. All over 10. Log base A, log base A, log base A. So this times this divided by this. When you see the division minus sign, the subtraction sign, you divide. So log A is what they all have in common. We are factorizing the whole of this. Log A, open the brackets, 270 times 1 over 3 divided by, because of this minus sign, 10 equals to 2. And we did something earlier when we look at the law of, when we're looking at logarithm. I said if we have log, for example, 2 base A equals to, okay, we are looking for the value of A in something like this. I said bring A down, forget about the log. This 2 comes here, and then it pushes this 2 up. This 2 becomes the base here. It pushes this one up. So A, the value of A becomes 2 raised to power 2, which is what? 4. So the same thing will happen here. Log, this one does not have a log. Assuming this has a log here, we would have done log cancels log. But this one does not have a log. So A now, this logarithm is gone. We are having 270 times 1 over 3. This year, we are having 90 all over 10. 90 all over 10, because 3 here, 3 into 70 is 90. 90 times 1 is 90. All over this 10 is equal to, this A now comes here and pushes 2 up, just like we've learned here. 2 comes here and pushes this one up. Then we look. So this equals to A raised to power 2, based on what you have learned here. So we have it this way. 90 over 10 becomes 9, equals to A over 2. Don't forget, indices, you have to be able to express your numbers in powers. 9 can be written as 3 raised to power 2 equals to A raised to power 2. They have the same powers. So this cancels this. Our A equals to 3. Our A equals to 3. Let's go back to this again. This is the question. Following the Bodmer's rule, we solve addition before we solve subtraction. So I'm arranging it based on the Bodmer's rule. Let's arrange this based on the Bodmer's rule. Log 270 plus log 1 over 3 base A. Both of them are in base A. Minus this also is in base A. Log 10 base A equals to 2. Log base A. All of them are in base A. Then we have 270 times 1 over 3. Times because of this addition sign, times 1 over 3. Divided by, because of this multiplication, subtraction sign, we have divided by 10. This 10 equals to 2. Equals to 2. That's what we have there. What we learned here, log A base 2 equals to 2. Forget about this logarithm. I'm just giving you the logic, the keys. We don't need to work with too much information. What we need here is the key. Now, the 2, forget about the log. The 2 comes here as the base and pushes this 2 already standing here up. A becomes this 2, pushing this 2 up, 2 raised to the power 2. A equals to 2 raised to the power 2 is 2 times 2, which is 4. The same thing applies here. Log A, which is carrying this, all of this, 270 times 1 over 3, all over 10. 270 times 1 over 3. 3 here, 1. 3 in 270 gives us 90. Thus, we are having 90 all over 10 equals to, like we learned here, A comes here and carries 2 up, pushes 2 up. A serves as the base. This logarithm is gone. We are having 90 over 10 equals to A raised to the power 2. 90 over 10 is the same thing as 9. 90 over 10 gives us 9 equals to A over A raised to the power 2. 9 can be written as 3 raised to the power 2, which is 3 times 3. 9 can be written as 3 raised to the power 2 equals to A raised to the power 2. This is 9 equals to A raised to the power 2. They have the same powers. 2 cancels 2. A equals to 3. So the value of A in this is equal to 3. The value of A here is equal to 3. Now this one says, express y in terms of x if log y base 10 plus 3 log x base 10 equals to 2. That's the question. Express y in terms of x if log y base 10 plus 3 log x base 10 equals to 2. Express y in terms of x. This phrase is another what they use for subject of formula. At least is to find the value of y. That is what you're asked to do. Find the value of y. So whenever you see this, it means find the value of y. Or whenever you see find the subject of the formula, make this such a particular letter subject of the formula, it means find the value of that particular letter. Don't be confused by the grammar. It's a mathematical language anyway. Express y in terms of x if log y base 10 plus 3 log x base 10 equals to 2. Let's do this again. Log y. Okay, now, both of them have the same basis. The two logarithms have the same basis. We are going to be having y plus, because we are adding the two logarithms, y plus becomes times Now let's look at this. 3 log 10, 3 log x base 10. Like I said earlier, if we have log a, log base a, and we have 3 raised to the power 2, this 2 comes here and becomes 2 log 3 base a. This power comes here. So it is as it is, without understanding that we know that this 3 that is here was actually a power here. So it means, okay, let's go back to that so we don't get confused. Let's go back to that. Let's take it step after step. Plus log base 10 x raised to the power 3. Another way of writing 3 log x is log x raised to the power 3, because this 3 coming here becomes log 3 log x base 10. So we are turning this around to the other side. So it looks like this one. Turn it so it looks like this one equals to log, equals to 2, not log 2, equals to 2. And so we have it this way. We move forward. Log 10, log base 10, log base 10, base 10. Let's factorize. We are having y. Because of this plus sign, we are multiplying the logarithms. X raised to the power 3 equals to 2. Remember this one on the other side, the right-hand side of the equation does not have logarithm. So, we see apply what we have learned. Log base 10. Y times x raised to the power 3 gives us x raised to the power 3 y. Y times x raised to the power 3 gives us x raised to the power 3 y equals to 2. I told you, forget this. This does not have a logarithm. If this had a logarithm, we would have said log minus log, then we get the answer straight. But this does not have a logarithm. Forget about this log. X raised to the power 3 y equals to, this 10 comes here and pushes 2 up. 10 raised to the power 2. Forget about this logarithm, because this does not have a logarithm. So this 10 comes here and pushes the 2 up. Thus, this 10 becomes a base, the 2 becomes a power. So, we are looking for y, expressing y in terms of x. What we are asked to find is y. Y, therefore, equals to 10 raised to the power 2, which is 100, all over x raised to the power 3. So, log x raised to the power 3 y equals to 2. This 10 comes here and pushes 2 up. That's the logic. X raised to the power 3 y equals to 10 raised to the power 2. 10 raised to the power 2 is 100, but we're looking for y. Y equals to 100 all over x raised to the power 3. So, expressing y in terms of x means that find the value of y. So, this is the answer. Y equals to 100 all over x raised to the power 3.